So in this lecture, we'll study Cartesian vector in 3 dimensions, right? And basically solving the problem in 3 dimension are greatly simplified if the vectors are first represented in Cartesian vector form. So basically, this is very important that in a 3 dimension, it is very helpful if we use Cartesian vectors. I mean, the major application of the Cartesian vector I, j, k is for the 3 dimensions, and you know that will follow the right hand rule. Like one of the axes will be x-axis, then another one will be y-axis, and then z-axis. And you know that x-axis mean I component and y-axis mean the j component and z-axis mean the k component. Let's say if we have a vector A, let's say this is vector A, and this vector A will have 3 components. One will be acting along x-axis, we call this as AX. One will be along the y-axis, we called it as a AY, and then another one is along z-axis, we called it as AZ. So the resultant vector A, since it has 3 components in 3 dimensions, so the resultant vector A will be AX plus AY and AZ. So this is for 3 dimension. And since this is the representation, I mean a x, a y, and a z, right, along I, j, and k. And we can also figure out the magnitude of that resultant vector, which is equal to the ax square plus a y square and a z square, right? And then let's discuss the direction of the Cartesian vector. Like that Cartesian vector, let's say this is vector A, right? This is vector A, and this vector A can have 3 components. Just I discussed. One is along the x-axis. This is called AX. One is along y-axis. That's called AY. Another one is along z-axis. That's called AZ. So each component of the vector A can have the direction cosine or the direction angle with respect to different coordinates. Let's say we have given different name. Let's say the x-axis, this is AX. AX has angle, let's say alpha with that vector, right? So AX has angle alpha. Let's say AY has angle beta with that vector. Similarly, the component AZ has vector gamma with that vector A. So that means alpha, beta, gamma mean the component, let's say AX has alpha, AY has angle beta, and then the AZ has angle gamma. That angle is with respect to the vector and its component. If component is AX, then the angle is A. The component is AY, the angle is B. And we know that, I mean, let's say from the 2 dimension, let's say if we have x-axis and y-axis, let's say this is the x-axis and other axis is the y-axis. And if we have a vector, let's say A, let's say this is vector A, right? Then what will be the AX? What will be the value of AX? And let's say this is angle theta. And what will be the value of AX?
A cos.
Or in other words, let's say, what is the value of cos theta? What is the value of cos theta?
AX.
Sorry?
AX over A.
A by AX. Yeah, A by AX or AX by A. Yes, that would be AX by A. So cos theta will be AX by A. That means if you know any angle, then the cosine of that angle will be that component, I mean AX divided by A. Similarly, in 3 dimensions, let's say if you want to calculate for the alpha, I mean the component AX, then what will be the value of cos alpha? AX, I mean the same component, AX by AY. Similarly, what will be the value of beta? AY by A. Similarly, what will be the value of gamma? AZ by A. That's called the direction cosine of A in 3 dimension, right? Now, there is an easy way that if you want to get a unit vector, now unit vector give you the direction of the vector. We can get the unit vector if we divide any vector with its magnitude, right? Let's say that vector is divided with its magnitude, then you will get a unit vector. And unit vector can also be calculated if you know these cosine angle. Like it has three components. One component is the I component, we call the cos alpha, plus cos beta, plus cos gamma, right? So this is very simple way to calculate the unit vector. If you know the three angle, I mean in three dimension, if you know three angles, you can easily calculate unit vector. So cos alpha I plus cos beta j plus cos gamma k, if you know three angles, or the square of these angle is equal to 1, right? So that means, let's say if there is any vector a, let's say any vector a, how can you express this vector? Let's say if you have a magnitude, let's say scalar a, right? That's, let's say force, let's say this is a force of 20 Newton. This is a numerical value. So how can you represent this force as a force vector? Because this is a numerical value. Can you represent this force in terms of force vector? I mean, force vector mean, how can you convert this numerical value, scalar value, into vector, force F? Then you need a unit vector, right? You need a unit vector and multiply with that force. Then it will become a vector, right? So how to get this unit vector? If you know the angles, then you can put that cos alpha I plus cos beta j plus cos gamma k, right? So this is how that a vector, I mean, if you know the scalar, then you can convert scalar into vector by multiplying a unit vector, whereas unit vector is equal to cos alpha I plus cos beta j plus cos gamma k. Or if you further simplify, we know that a cos alpha is equal to ax. Similarly, a cos beta is equal to ay. Similarly, a cos gamma is equal to ak. So that means we have proved that even in the three dimension, a vector is a sum of axi plus ayj plus ayk. So that means we can apply the same rule as we apply in the two dimension. I mean, we can add the vector as well in three dimension. If there is a vector a and there is a vector b, we can add up by applying the same rule, like a plus b. So we have to, I mean, join the component of phi and the component of j and the component of k in vector addition. So the resultant force will be the sum of the component, like sum of all the component of x and sum of all the component of y. So that, and sum of all the component of k. I mean, you have just to add the third dimension, this one. Previously we discussed up to two dimensions, so this you have to add this component, k component, then it will be the addition of vectors in three dimensions, just like this one. So if there is vector a and vector b, so this is the sum using parallelogram law, but this is addition in all the three dimension. You have included the az plus ab as well. So let's try to practice what we have learned the theory. For example, this is an example of a lathe machine, let's say lathe machine, and a piece is inserted in the chuck of the lathe machine. Let's say, you know that when we, I mean, cut that piece, if we reduce the diameter or if we reduce the length, normally we place a tool here, right? Either we place tool on the surface or in front of this, right? So let's say here there is a force, maybe when the tool come in contact with that piece, it apply a force. Let's say that force is given 60 Newton, right? And that force, the angles are given like this angle is the angle with the x-axis. So what is the name of that angle? 60 degree. What is the name of that angle?
Alpha.
Alpha. Yes, this is alpha basically. And then there is another angle of that force with the z direction, that's called gamma, right? And then the force angle with the y-axis, that called beta. The question is, what is the value of the beta? First of all, what is the value of the beta? And then express the force as Cartesian vector. So this force is a scalar quantity now because this is given 60 Newton. The question is express the force as vector. I mean, how, I mean, the scalar value is given like F is equal to 60 Newton, and convert this scalar value into a vector force, right? How can we convert that force vector? How can we convert? A scalar
I'm
force into a,
multiplying with unit
yeah,
vector.
multiply with a
Unit vector.
unit, yeah, with a unit vector. So that means you need a unit vector and then you multiply with the scalar force, then you can convert a force vector. But first of all, we need the value of the beta. We know the three angle and one angle is missing. We know that cos square alpha plus cos square beta plus cos square gamma is equal to 1. So using that formula, we know two angle, I mean alpha and gamma, we can calculate the value beta. So if we simplify, we'll have plus minus 5. So there is two possibility, 60 degree or 120 degree. So which angle is possible? Which angle is possible?
120.
Why
Yes, sir,
120?
120.
Why not 60?
Because the angle is greater than 90.
Yes, you are right. Basically,
Clockwise will be
ji-
60 and when we measure it counterclockwise so it will be 120.
uh, basically, yeah, you are right. Basically, sum of the angle alpha, beta, gamma. I mean, this angle, you can see that from x-axis up to y-axis. What should be the total angle? I mean, from x-axis to z-axis is 90. Similarly, z-axis to y-axis is how much? 90, because these
90.
are, yeah, these are perpendicular to each other. So that means the total angle possible is 180. So if this is a 60 up to here, then obviously the remaining should be equal to 120, because a 60 is not possible, right? 60 is not possible. So that means the beta angle is 120. So this was the first part. Second part is to calculate the force as a vector. So that means first of all we need a unit vector. So how can we get a unit vector if we know the angle? How can we get a unit vector? Simply cos alpha I plus cos beta j plus cos gamma k. So using that, I mean cos alpha I, cos beta j, that's the unit vector. So if you multiply that unit vector with the force, this is the force, multiply with the unit vector u, and that u is equal to, when you know the angle, that is equal to cos alpha I plus cos beta j plus cos gamma k. So if you multiply, simplify, this is the in the vector form. So force was this 60 Newton was in scalar form. So if you multiply with the unit vector, now this is a vector form of that force. Right. Let's try to solve another example. For example, here we have a beam now. So let's say that beam is connected with two ropes, let's say, and they are, I mean, pulling that beam by applying different forces. One force is, let's say, 630 pound. Another force is, let's say, 250 pound, right? And different angles are given in that problem. The question is, the beam is projected to two forces. Express each force in Cartesian vector form and determine the magnitude and coordinate direction of angles of the resultant force. So first of all, you need to express each force in vector form, right? I mean F1 in vector form and F2 in vector form. Let's say to convert F2 into vector form, what you need is, let's say, how can you convert F2 into vector form? I mean F2 as a vector form, you have the scalar value, so you have to multiply with a unit vector. Simply, you multiply with a unit vector, that force, then it will become a vector, right? And how can you get a unit vector for this case? I think all the angles are given. Yes, alpha is given, then the gamma is given, then the beta is given. So beta is 135, gamma is a 60, and alpha is 60. So there is no problem for this case, F2 case. We can convert simply by multiplying with the unit vector. What about F1? How can we convert F1 as a vector force? Let's say F1 as a vector. So again, we have to multiply with the unit vector with that value, F1, right? So what will be the unit vector of this force? Since angle is not given, in that case, I mean, this force will have how many component? This force will have how many component?
3 components.
No, it will have 2 component. One component will be along the y-axis, right? And the one component will be along the z direction, because there is no movement along the, I mean, there is no angle or the dimension given along the x-axis. So that means that force is just lying on the y and z plane, because there is no, I mean, movement given along the x-axis, whether in that in the positive x-axis or whether in the negative x-axis. So that means if you want to know the component along the y-axis, that is like, I mean, fy, let's say. So that means you need a parallel to this one, and parallel to this one is 7, right? 7, and how much is the hypotenuse? 25. So 7 by 25 multiply by the total force. And what is total force? 630. Right, so that will give you a component along the y-axis. Similarly, the component along the z direction is negative, because this is in the negative z direction. So how can we get this component? I mean, fz component. So what is parallel to this one is 24. So that will be 24 divided by 25 multiply by that force, total force, and that total force is 630. And but this component will be negative. So now this is a unit vector for this force. So you multiply that unit vector with that force, then you will get this force as well. And then the third one is how to get the resultant force. How to get the resultant force? You have to add up, because now you have two vector force. This is also in vector form. This is also in vector form. So resultant force Fr, you just add up these vector, F1 vector plus F2 vector. Then you separate the component of I and J, and then that will be your resultant vector. And how can you get the magnitude of that resultant vector? You know that how to get the magnitude. You take the square root Frx square plus Fry square, and that will give you the magnitude of the resultant vector, right? Right. So first of all, this F1 can be converted into vector by multiplying with the unit vector. So this force has multiplied with the unit vector. Similarly, you simplify, this is the in the vector form, right? Similarly, the F2, we know the, I mean, this is cos alpha I, cos beta j, cos gamma k. You multiply the force 250 with that unit vector, then again you will get the F2. And how to get the resultant force? You add up the forces, F1 plus F2. You have add up that forces. And how to get the magnitude of this resultant force? I mean, you take the square, this square, this square, this square, and then you take the square root. That will be the magnitude of this force. How to get the cosine angles? Anyone can answer me? How to get the cosine angle of a resultant force? How to get the cosine angle of this resultant force? Anyone? How to get cosine angles?
We have the magnitude and the Fr in the Cartesian form, so we will first find the unit vector and then equalize, compare it with the cos alpha with I component and cos
Now,
beta with J component, and
what is the value of cos alpha? What is the value of cos alpha? For example, in case of, because we want to calculate the result for the resultant force, cos
it will
alpha will be equal to,
125 over 496.
I mean, fx component,
Yes.
fx component divided by f.
Fr.
F.
Yeah, I mean, this is the resultant force. So what is x component? 125. And what is the total magnitude? 496. So similarly, you have to take the cos inverse, then that will be the value of the alpha. Similarly, cos beta, what is the value of cos beta? I mean, this component, fy component divided by f, right? So now f component is minus 0.3767 divided by this magnitude, that will be beta. Similarly, cos gamma will be equal to fz, right? Fz divided by f. So that again you take the cos inverse, that will give you the value of alpha, beta, and gamma. So this is how you can the alpha, beta, gamma of the resultant force. So for any force, right, if it says for the resultant force, then you have to take for the resultant force, I mean this cos alpha, cos beta, cos gamma with reference to the resultant force. If it says, I mean, let's say for this one, then this is equal to cos alpha. Similarly, this one is equal to cos beta. You have to, I mean, understand this. Please try to practice for the three-dimensional cases how to figure out the cosine angles and how to express a scalar into a vector. So these are the related problem that we have studied up till now. Right? Next very important topic is position vector. So position vector is basically, this is very important in 3 dimension as well as in 2 dimension. When you use vector Cartesian coordinate system, position vector is very important even in the force, in moment. So please, I need your focus to understand the position vector. A position vector is basically a fixed vector which locates a point in space relative to another point. Now another point could be an origin, it could be any point in the space. So that means you can specify any point in the space with reference to some certain points. For example, here is a point, let's say point is point P. So this point P can be located, its position can be described using a position vector R. There is the position vector of R which can specify the position of point P. Please remember, every time you have to start from the origin. I mean, from origin, how can you reach to this point P? That's the main function of the position vector, that from any fixed point, how can you reach to this point? So how can you reach to this point? First of all, you need from the position vector to move in the X direction, right? And then you need to move in the Y direction, and then you need to move in the Z direction. So then you can reach to that point. I mean, here is a distance of this point from the origin to the X axis, then you go to the Y axis, and then you go to the Z direction, right? So that will be the position vector of this point. So that means from here to here is the distance is Xi. This is the component Xi plus Yj, right? This is Yj plus Zk. So that would be the position of the that point P. So Xi mean from the origin Xi distance, then Yj, and then Zk. So that will give you the position vector R. Right? Let's say this is, I mean, this is in the form of the vector notation for the above point, right? Let's say here we have 2 points, point A as well as point B, right? Here is a point A and point B. Let's try to calculate the position of point A. So how can we calculate the position of point A? I mean, we have to start from the origin. We have to start from the origin. Let's say the position vector of A mean, let's say RA, right? RA mean the position vector of A, right? So that means if we start from the origin, we have to move, let's say how much we have to move in the x-axis direction. Let's say this is in the x-axis direction. We have to move up till here, right? And then y direction we have to move up till here. And then in the z direction, we have to move in the negative z direction, right? Up to here. And then we can reach to that point. So this is the position of A. So how much is the distance in the x-axis? 4. Because this is, yeah, this is parallel to this one. So 4, comma, how much is in y direction? 2. So 2, and then how much is in k direction? Minus 6. So this is the position vector of point A. We can also express this position vector in terms of I, j, k. I mean, the above position vector can be written as 4i, right, plus 2j minus 6k. Right? So that's the position vector we say RA, right? Position of point A with reference to origin, right? What about the position vector of point B? Let's say RB. What is the position vector of point B? Right? So again we have to start from the origin, right? We have to start from the origin. I mean here, how can we reach point B? First of all, we have to move in the x direction. Let's say from here up to here. How much is that distance? Up to here?
6.
6. I mean 4 plus 2, 6. And then we have to move in negative y direction. How much in negative y direction? 1. And then in positive k direction 4. So that means the coordinates of this point B will be 6, 6i, and then minus 1j, and then plus 4k. So that will be the position of point B, right? So here is the position of point A and position of point B. So I hope that you can specify the position vector of any point in the space. Is that clear to everyone?
Yes, sir.
Right.
Yes, sir.
So, I mean, not only we can specify the position vector of any point in the space, with reference to the origin, we can also specify with reference to any point in the space. Let's say we have 2 points, let's say point A as well as point B, right? So we can also specify the position of point B with reference to point A. Like, I mean, please look at the head. When the head is towards point B, that means it is asking the position of point B with reference to A, right? This is the direction. I mean, you have to see the direction of arrow. That means position vector of B with reference to A. Normally we represent it as RB/A. So what is the meaning of RB/A? Mean position of point B with reference to point A, right? So that will be equal to normally RB. Please note that these are vector. This is also a position vector. This is also a position vector. So RB minus RA, right? So that means position vector of B with reference to A is equal to RB minus RA. That means position of B with reference to A. And how we figure out RB? Position vector of B with reference to origin. What is RB? That means position of B with reference to origin. And that value is given XB, YB, and ZB. Similarly, what is the position vector of RA? RA means position of point A with reference to origin. So that is XA, YA, and ZA. That means we have to subtract. In order to get RB/A, we have to subtract XB minus XA, I. Right. Similarly, YB minus YA. Similarly, ZB minus ZA in order to get the position of point B with reference to point A. Right. So this is how we can calculate the position of position vector R. Right. That's RB minus RA. Similarly, let's say if I say to calculate the position vector of point A with reference to B, then first of all, I mean, if I say let figure out the position of point A with reference to point B, then it will be RA minus RB. Right? Now it will be RA minus RB, right? And now the direction of this arrow will be reversed. Now the direction will be in this direction. That means now we want the position of A with reference to point B, right? So this is the position vector. I mean XB minus XA, YB minus YA, right? So and this is the graphical representation. Now let's try to solve a couple of numerical problems to understand this concept. For example, this is an example of an elastic band is attached to a point A and B. So this elastic band is attached with the point A and that point B. Determine its length and its direction measured from A towards B. So how can we figure out the length? I mean, how can you figure out the length? Length means the position vector. First of all, you need a position vector, and the magnitude of that position vector will be the length of that string. So basically what you need is, first of all, you need a position vector from A to B. right? So that means you need a position vector, this one, from A to B. And then how can you get the direction? To get the direction, you need a unit vector. How can you get a unit vector? You can get a unit vector from the position vector. I mean, if you divide a position vector, with its magnitude, right, then you will get a unit vector. Then unit vector will give you the direction, because a unit vector represents the direction of a vector. And which vector we need? We need a position vector. Which position? From A to B. So basically what we need is, we need a position vector. This R is basically the position of B with respect to A, right? So that means, and this is equal to RB minus RA, right? And how can we get RB? RB mean the position of B with respect to the origin. Similarly, what is the meaning of RA? Position of point A with respect to origin. So what is the, I mean, coordinates of B? Let's say, let's try to calculate first of all the coordinates of B. Again, for the coordinates of B, we have to start from the origin. I mean, from origin, how can we reach point B? So if we start from here, we have to move from here to here, right? I mean, in the y direction. How much is that? 3. No, that's 2, right? This one, because this from here to here is same as from here to here, right? That's 2 meter. So we have to move from here to here in y direction, and then in a negative x direction from here to here. How much? 2 meter in a negative direction. And similarly in positive z direction from here to here, and then we can reach point B. So that means the coordinates of the point B is, this is in the positive y direction. How much? 2 meter. So 2j. This is 2j. And similarly, we have to move in the negative x direction. How much? 2 meter. So minus 2. So minus 2i. So minus 2i plus 2j and then plus 3k. So this is the position of point B, right? And now let's see, try to figure out RA. I mean, position of A with respect to origin. Again, for the A point, we have to start from the origin. We start from the origin. Let's say we have to move up to here. And how much is that distance? This is in the positive x direction. This distance is equal to this one, 1. So 1i, and then we have to move down. Down mean in k direction, 3k. So that means j is equal to 0, because we don't need to move in the y direction. Just we start from the origin, 1i minus 3k. So 1, 0, minus 3. So that's the position of point A. Now how to figure out that position vector? We have to subtract RB minus RA. So what will be that value? Minus 2 minus 1 minus 3, right? Similarly 2 minus 0, 2, right? And then 3 minus 3, that will be plus 6. Right? So this is the position vector RB slash A, position of B and A. So this is a vector form. That means minus 3i plus 2j plus 6k. So that's the position vector. So once we have position vector, we can get its magnitude, right? Magnitude. How can we get that magnitude? We have to take the square root. I mean, minus 3 square plus 2 square plus 6 square. That will give you the magnitude. And finally, how to get a unit vector? We have to divide the position vector with its magnitude. That will give you, I mean, this is point A, right? And then this is point B, right? This is point B, right? And then once you have that, then you have to subtract this one. And then you will get finally minus 3i plus 2j plus 6k. So then you need a magnitude. So this formula you can use, and then you can get the magnitude. So this is the magnitude. And finally, how to get the unit vector? Because unit vector will give you the direction, this one. right? And unit vector will be if you divide a vector with its magnitude. Magnitude is 7, so you divide the vector with the 7, that will give you the direction one, right? So this is how, and even you can get the angles. How can you get the angles? For example, let's say if I say what is the value of cos alpha? What is the value of cos alpha? Anyone? What is the value of cos alpha?
Sir, 3/7.
Yeah, minus 3 by 7. Very nice, right? Because this is a unit vector. So the first one is cos alpha. What is cos beta? The second one. And what is cos gamma? This is the second one, right? So if you take the inverse, then you can get the alpha, beta, gamma, because you have to take the inverse to get that angle, right? Let's see another numerical problem. If you read that statement, express the position vector r in Cartesian vector form. So you need to get a position vector r. Where is that position vector? This is the position vector from A to B. A to B mean you need basically r b slash a. That you need this one. So that means you need again the rb minus ra. So basically you need the position vector of the point of A as well as point B, right? So let's first try to calculate the coordinates of B first. Let's say, what are the coordinates of B? We have to start from the origin. If we start from the origin, we have to move in the y direction. How much we have to move? Up to here. How much is that distance? 8
8 feet.
8 feet. And then we have to move in the z direction to reach at point B. So this is how. So we move in the y direction, 8j plus 2k. So the coordinates of point B is, there is no x direction, so 0, comma, 8j, comma, 2k. So that's the position of point B. Similarly, we have to figure out the position of point A. How can we get the position of point A? We have to start from the origin. From origin, if we start that, we have to move in the positive x direction, this much, right? And then we have to move in the positive j direction, and then we have to move in the negative k direction. So basically we need these 3 dimensions, this one, and this one. So how to get these directions? For example, how to get this direction? Basically this direction, this distance is equal to this distance because this is parallel. These are parallel to each other. So how to get this distance? Similarly, this distance, this parallel distance is equal to this distance from here to here because they are parallel to each other, right? So how to get this distance? That's the second thing. Similarly, how to get the vertical distance? This one. This is very easy because this is in front of the angle. We know the hypotenuse, 5 feet, and we know the angle. So what will be that value? What will be that value? Anyone? What will be that value? 5 sine 20. Right? This is 5 sine 20. And how to get this value? We cannot get this value until we have this hypotenuse. How to get this hypotenuse? Because in front of the angle is a 5 sine 20, and what is that value? 5 cos 20. So if it is 5 cos 20, then what is this value? What is this value? 5 cos 20 sine 30. Right? Everyone got this point?
Yes, sir.
So how to get this one? How to get this one? How to get this one? So that will be Yeah, 5 cos 20 cos 30. Right, 5 cos 20 cos 30. So now we have all the three coordinates of A. I mean, we know this length, we know this length, we know this length. So the coordinates of the point A will be equal to, how much is in the x direction? This x direction is equal to this one. And this value is equal to 5 cos 20 sine 30. 5 cos 20 sine 30, right? This is I component. And then from here to here we move in the y direction. And what is that value from here to here? That is equal to this one, which is equal to 5 cos 20, right? This is equal to 5 cos 20 cos 30, right? Similarly, what is the value in the negative z direction? This will be minus negative. So this value is equal to simply 5 cos 20, right? This value is simply, this front angle is 5, so 5 cos 20, 5 sine 20, sorry. So this is the position vector of A and B. Remaining is very simple. You know how to do the remaining. Remaining, I mean, you know the position of B and you know the position of A. So how to get RB minus A? RB minus RA. I mean 0 minus this, 8 minus this, 2 minus this. So you simplify, that will be the position vector. So once you get the position vector, let's first calculate the position vector. Let's say, let me erase this. Right, so let's see, this is the position vector. I mean RB minus RA, right? So I mean, I'm taking the minus, there is a position vector. So once you got and you simplify that one, then you can calculate the magnitude of the resultant vector. So once you have that position vector and its magnitude, then getting the direction cosine is not a problem. Then you need a position vector. And how can you get that position vector? You have to divide a vector with its magnitude, then you will get a position vector. So the position vector will be, I mean, this one, and then position vector, you have the alpha. I have skipped one step. I mean that position vector will be equal to the position vector divided by its magnitude. And what is position vector? This is the position vector and this is the magnitude. So then you will get, I mean, if you divide this one with the 5.89, you divide with 5.89, that will be a unit vector u, right? So minus 2.35 divided by this one will be cos alpha. Then 3.93 divided by this one cos beta. Similarly, this one divided by this one cos gamma. And then you take the inverse, that will be, you can get the angles. So this is how you can get the direction cosine as well as the unit vector. So is that clear to you?
Sir, I have a question.
So you understand that?
Sir, I have a question, sir.
Hello?
Hello.
Yes.
I have a question, sir. Sir,
जी पूछिए.
if we have calculated the angles, direction angles alpha, beta and gamma for R, A, B, so sir हम ये जो वेक्टर है इसको हम कोऑर्डिनेट सिस्टम में किस तरह रखेंगे और फिर एंगल्स किस तरह ड्रॉ करेंगे अल्फा, बीटा और गामा? आप काइंडली फिगर ड्रॉ करके एक्सप्लेन कर सकते हैं?
देखें, ये तो हमने जब लेक्चर्स स्टार्ट किया था तो हमने डिफाइन किया था कि अल्फा से क्या मुराद है. लाइक इफ देयर इज एनी वेक्टर, लेट्स से इफ वी हैव थ्री coordinates, let's say we have three coordinates, one is y and there is z and there is x, right? Any vector, इस केस में हमारा वेक्टर कौन सा है? अ यूनिट वेक्टर है. कोई भी वेक्टर हो सकता है. लेट्स से आई से a vector, let's say this is our a vector. I mean, I'm taking a generic one, right? Instead of u, I'm taking, let's say, a. So we know the definition of alpha, that any vector a, alpha mean with x-axis, right? Beta mean with y-axis, right? Gamma mean with z-axis. So similarly, if you have a position vector, this is our position unit vector, right? Unit vector mean minus 2.35 divided by 5.89 I plus 3.93j divided by 5.89. So this will be our position unit vector. So similarly, I mean the first component, I mean if you have alpha, beta, gamma, then instead of a, you should put a unit vector u here, and then you can specify what is the value of alpha, right? Alpha is 130. That means from here to where that unit vector lie, that angle will be 130. Similarly, the beta and similarly the gamma. You got that?
Yes, sir.
Right. So can you solve this problem? Please think about this problem and try to solve yourself. Please read the statement. Like in this problem, determine the length of the member AB. So calculate the length of this member AB of the truss. Now that the word truss mean if you have different frame and you connected with a bracket, this structure is called a truss. Right? This structure is called a truss. Normally you will see this type of structure on bridges or on the roof of any industry. You will see those trusses. And the question is, you need to calculate the length of this one AB by first establishing a Cartesian position vector from A to B. So you need a position vector from A to B, and then you can calculate its magnitude. That will be equal to the length of that member. So that means basically you need a position vector first. R, you need first of all RB/A, right? And RB/A mean RB minus RA, right? And that mean RB minus A mean you need a position of point A as well as position of point B. So what is the position of point A here? I mean you have to start from the origin. This is a 2-dimension, not 3-dimension, because just Y and X is mentioned. So that's a 2-dimension. So what will be the position of A now? We have to start from the origin. How much we have to move in the X direction? This much. And what is that? 0.8. And then from here to how much in the Y direction?
1.2.
1.2. So this is very simple. The position is 0.8, comma 1.2, right? What about the position of B? How can we reach point B? Again, we have to start from the origin. From origin, we have to move from here to up to here, right? We have to move up to here, right? From origin, we have to move up to here, and then from here, we have to move in the vertical direction. So that means from here to here is 0.8 plus 3, 1.1, right? Yeah, 1.1, right? 0.8 plus 0.3, 1.1. So from here to here is 1.1. And then further we need from here to here. We know that this angle is 40 and the perpendicular is given, which is 1.5. So we can use tan theta. So that means tan 40 is equal to perpendicular divided by base. That means 1.5 divided by, let's say from here to here is, let's say X. So this X. So X will be equal to, I mean you can calculate that X. That X will be equal to 1.5 divided by tan 40, right? So that means now we can have the X as well, right? So we can know the position of point B as well. So position of point B mean in the X direction we need 1.1 plus 1.5 divided by tan 40, right? Divided by tan 40, comma, how much is the Y direction? 1.5.
1.5.
Right. So this is the position of B. So how to get the position vector RAB now? B minus A, right? So that means this component minus 0.8, 1.5 minus 1.2. So that will be RB/A. And how to get the magnitude? You have to take the square root. That will be the magnitude, and that will give you the length of this one. So you can see in the answer, like first of all, we calculated RB minus RA. RB means this component minus 0.8. So minus 0.8, that will give you I. Similarly, 1.5 minus 1.2. So that will give you the J component. So this is the position vector. So if you take the magnitude of that position vector, that will give you the length of A and B, and length is equal to 2.11 meter, right? That means position vector is very important. Again, for this section of the book, please practice this problem, right? So that's the end of this lecture. If you have any question, you can ask me. Is that clear to everyone?
Yes, sir. Clear.
Right.
Yes.
Please start preparing because we have 6 weeks only, and there will be regular quiz and assignments. Maybe within a week you can have 2 assignments and 2 quizzes. So that's why you need to do your work every day. Right, whatever you read, whatever I suggest you to practice, please solve all those problems on the similar day. On coming Friday, you will have 1 assignment and 1 quiz. So be prepared.
Okay,
And
sir.
tomorrow's lecture will be included in that, right? So if you have any further question, you can ask me.